Hello everyone, welcome to a pre-recorded LeetCode stream. Today was a very interesting day for me because today was the first day that I went back into the office. So a lot of things changed today. I didn't realize how much being in an office can just sort of like physically drain you. And so the stream I did today was not one of my best streams. I'm frankly not very happy about it, but I feel like it's important that I continue to put out content. And I think in that way, you all might be able to relate to me a little bit better. Sometimes when we're struggling with things like LeetCode and things that are just hard, it's nice to be able to relate to someone and feel like, okay, I can also have a bad day. I don't have to be on top of my A game every single day. So with that being said, I wanted to make this video so that when I'm on vacation, you all have something to look at and just have fun with. So we're going to start off today with minimum difference between highest and lowest of k scores. So it says we're given a zero index integer array nums where nums of I represents the score of the ith student. You are also given an integer of k. Pick the scores of any k students from the array so that the difference between the highest and lowest scores of k scores is minimized. Return the minimum possible difference. There's one way to pick scores of one student. The difference between the highest and lowest score is 90 minus 90, which is 0, okay? So 9, 4, 1, and 7, there are 6 ways to pick scores of two students. It wants us to pick the scores of any k students from the array so that the difference between the highest and the lowest of the k scores is minimized. I see. So we have, what are the highest two scores? 9 and 7. The lowest two scores are 1 and 4. So I think we want what? 7 minus 4, which is 3. Oh, minimum possible difference is, so the highest is 9 and 7, right? Highest is 9 and 7. The lowest is 1 and 4. We want to minimize the difference between, let's see, difference between the highest and the lowest of the k scores is minimized. So there are 6 ways to pick scores of two students, 9 and 4. The difference between the highest and lowest score is 9 minus 4. The difference between the highest and lowest score is 9 minus 1. Difference between the highest and lowest score, okay, 9 minus 7. So wait, do we just want the closest, the highest and lowest score? 7 minus 1 is 6. The minimum possible difference is 2. Pick the scores of any k students from the array so that the difference between the highest and the lowest scores is minimized. Okay, I see. So if we have an array of like 5, let me see, how many scores are we dealing with here? Nums.length 10,000 or 1,000, and this is the amount that we're dealing with. Like, we're just going to pick some set of students, and then from there we want the ones that are like closest together. Like, what if we I'm almost thinking like, what if we sort them? What if we sort them and then we have a window, and in that window we can just see the closest that any of the numbers are? Because let me see, what will k be? Does it give us what k is? Oh, 1 is less than or equal to k, so it's going to be at least 1. There's one way to pick scores of one student. The highest and lowest score, 90 minus 90. The minimum possible difference is 0. Return the minimum possible difference. Like, if we have 1,000 numbers and we can only pick 2 of them, yeah, you know, I feel like we can come up with a window. If it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1 and 2, then we can always look of, or let's say k was like 4. We'll look at windows of size 4, right? And in this way, we just sort of like, we consider this window first and then this window. We always look at the highest and the lowest. Or I guess we can always look at these two to minimize the difference. If we pick those two. Now, if we had k equals 2, if it was 1479, k equals 2, the highest and the lowest, the minimum. Yeah, I think we can do something like that. Now, in the case of 1, k equals 1, 0 equals 1, 1 is already out, so the output is 0. Yeah, there's got to be a nice way to do this, but I'm thinking of sorting this, doing something like const sorted equals nums dot sort a minus b, and then sort of trying to create that window where I can have let start equals 0, let end equals k, and now we can say for let end, or I can say for let end equals k, k less than sorted dot length, end plus plus. So we can do this. I guess I don't even need that. I can say here let min equals some large number, and we can say math.min is min or nums of end, nums at end minus, would it just be nums of n minus 1? So why would I need to even consider the highest and lowest of k scores? Let end equals k. I guess here we can do nums of end minus k. So like, let's see what this means here, right? We have 9417, which ends up being 1479. So end is equal to k, which in this case k is 2, so end is here. K is less than sorted dot length, n plus plus, math dot min, and maybe n should be equal to k minus 1. That way we do something like this where end actually starts here. So here we'll say math dot min of min, which is infinity, or nums of end 1 minus nums of end minus k. So that shouldn't be 2. It should be whatever is in the beginning of that window, which could be n minus k plus 1. So it could be 1 minus 2, negative 1 plus 1 is 0. So it will effectively be these two things. And then again, we go to the next thing. Here we'll say 2 minus 0, right? 2 minus 2 is 0 plus 1 is 1. We just do 4 and 7. Okay, now we get to the next one, which is here. 7 and 9, that's 2, and that ends up being the lowest one. Now for this last one here, there's one way to pick scores of one student. Nums is 90. If that was 90 and it was sorted, it's still the same. End is k minus 1, so it's 0. Math.min of infinity, or nums of 0 minus, so 0 minus 1 is negative 1 plus 1. I think that will still give us 0. So I think here we can do return min. I want to run this real quick. If this works, let's see. Are we getting it? Is it time limit exceeded because of sorting, or because maybe I have an issue with my loop here? For let end, n plus plus, k less than sorted dot length, n plus plus. Okay. So is it, the thing is it time limit exceeded because, let's see. Output infinity. Okay. K less than sorted dot length. So let end equals k minus 1, which is 0. Okay, end minus sorted dot length, or end less than sorted dot length. Let's run this one, see what this gives us. Still infinity, okay. So let end equals k minus 1, so here n will be 0. 0 is less than sorted dot length, which should be 1, n plus plus. Math.min of infinity, or, again, I'm doing nums, this should be sorted. Well, it'll still be the same thing, right? So sorted of end, which is 0, so that's 90, minus sorted of 0 minus k, which is negative 1, plus 1 is 0, so 90 minus 90 is 0, and the minimum is 0. So again, we're not setting min here. That's what's going on. It's been a weird day. It's really been a weird day. I'm telling you, like, yes, being in an office could be draining. 0 and 2, 0 and 2. Let's see if we get the answer here. Okay, 22.35. I'm betting that we know the bottleneck here is going to be the sort, right? It's going to be an n log n operation. There's probably a way that we can do this much faster, and that's why we're getting, well, okay, 93.85. Let's keep going and see. Again, 93.85. So I'm now suddenly my confidence is increasing. Okay, let's see discussions. Sort and skip. Okay, so this is the same that we did by setting minimum equal to the max, right? We sorted it. Oh yeah, and there you go. Int I equals k minus 1, I less than nums.size, plus plus I, res equals min. Perfect. Interesting for using begin nums, C# version, nice and clean. Nice. Yep, I really do like this version. And I'm glad that it actually lined up with this person, which is like the best LeetCoder out there. That certainly feels great. Awesome. Let's get to another question here. Is this still on the same? I think we're good here. Minimum difference. Okay, maximum difference between increasing elements. So seems like it can be a similar question here. Given a zero index integer array nums of size n, find the maximum difference between nums of I and nums of j. In other words, nums of j minus nums of I, such that I is less than j and n, and nums of I is less than nums of j. Return the maximum difference. So we want, now this, I feel like we can't, yeah, there is no I and j such that I is less than j. Okay. So here, okay, this reminds me a lot for some reason of this question called best time to buy and sell stock, because I feel like if we draw this out, let's open up ExcalaDraw. So we have one, let's imagine we have like some imaginary thing here, right? Or maybe we can, let's make this a little bit nicer here. We'll go up to 10 here. So 1, 2, 3, 4, 5. Let me just copy these. And then 6. Okay, so let's just say this is like up to 10, right? So let's say here we start at 1. Make this bigger. So start at 1 here, 2, 3, 4, 5. We'll go to 5. Then we'll go to 2, and then we'll go to 10. Let's say it's up here. So we want to find, like, we want to get the lowest one. Actually, this is, I think, exactly similar to best time to buy and sell stock. We can keep going. Like, we want to find a very low number, and anytime the numbers are greater than that low number, we can keep tallying up our maximum. So 7, okay, that can be like our current minimum. Then we get to 1. That's smaller than our previous number, so that's the new minimum. And 5 and 4 are greater than 1, so we keep like anytime we find a number greater than the minimum, we do the subtraction 5 minus 1, and that's how we get. I think this is exactly like the best time to buy and sell stock. So we can say here, let max equals negative infinity. And let's see, let max difference equals, let's say 0. Is that what I'm looking here? Maybe I need let max equal infinity. And let's say min. Let's say let min equal nums of 0. Here we can say for let I, we can actually start at 1 here. I less than nums dot length. I plus plus. If nums of I is less than min, then here we'll say min equals nums of I. Else, what we want to do is we want to say max equals math.max of max, or nums of I minus min. And then finally, we should just be able to return min. Now, maybe min output -1 because we never found. So maybe here I can set max to equal to -1. That way, if this never happens, then max stays as -1. And here we should return max. So let's see what this is. So 4 and 4. So that's good on that one. 4, -1, and 9. Yeah, let's just submit this and see. Oh, so close. I really felt like we were onto something there. And unfortunately, this is such a large, this is such a large input. Let's see, where is it 0? Oh, so can I be such that 0 is less than or equal to I, which is less than j, okay. And nums I is less than nums j. So it said 0. I'm guessing it said 0 because of this 26 in here. Oh, there's also 102, 102. So it's like, okay, 997 is smaller, 980 is smaller. So we need to find, yeah, they need to be less than, but nums of I is less than nums of j. Oh, I see. Okay. It was 0, but okay, so if nums of I is less than min, then max is equal to math.max. Okay, I see. Because here, maybe I can keep saying, I wonder if I can do this. If it's less than or equal to 4, -1, and 9. Let's take this one here. Okay. Okay, 90.09. Very nice, very nice. This is a very good question. I would be so surprised. Next challenges, can we see similar questions? Best time to buy and sell stock. Yeah, it's literally the same exact template. It's the same question. It's crazy. So it's a linear time algorithm with a constant space complexity, my favorite type of algorithm. Prime, and anytime I see prime, I think math, and I'm like, nope. Return the number of permutations so that prime numbers, I don't really care for prime numbers. Let's just go to the next one. Given an array of integers nums, calculate the pivot index of this array. The pivot index is the index where the sum of all the numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index's right. Okay. I think the way that I've definitely seen this question before. Pivot index is 3, 0, 1, 2, 3. 1 plus 7 plus 3, which is 11, is the same as 5 plus 6. So if you think of like pivot index equals left sum because there's a way to do it, and that way you don't have to have like multiple arrays, if that makes any sense. Because we can do this by having like more space to hold more arrays, but we might be able to like get away with it here. Give me 1 second. I'm gonna shoot a text message. So I wonder, like, if we pivot index equals the, maybe there's another way of doing this. If I had like total sum, if it was like 11, here's 11, and then what, 17, 22, and 28. Sum of all, well, the sum of all the numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index's right. How do I express that? Like in an equation, because it's like left sum plus the right sum. Pivot index equals, it's not so much that like left sum, or I guess we can say the left sum minus, I guess whenever 0 equals right sum minus left sum, and that's like pivot index. Whenever that becomes the case, but I'm trying too hard right now to like remember a question I did before. If I knew ahead of time each one of these, like 1, 8, 11, and then what, 18, 22, 23, and 29. Is that what it is, right? Because 1 plus 8 plus 3 is 11, plus 6 is 17, 22, and 28. See, because then you just got to do it the other way, right? So as soon as we get to here, we can start doing the prefix sum backwards, and we'd get the same thing. But I feel like there's a much better way of doing it though, and that's how I want to try and figure it out. I might have to wrap it up though, because I do have some food waiting for me. And food is good. Make sure you eat your food, guys. What is the formula here? The Krabby Patty formula. Return the leftmost pivot index. If no such index exists, return -1. Yeah, let's wrap it up here, and then let's save this one for like another recording or another LeetCode live session. I think this will be better suited for a LeetCode live. We have a little more time. It's a little bit earlier in the day, not having to like cram for time here. So I'm pretty happy with what we did. I think we did like 2 or 3 questions, maybe 2 at least. I think 2 is good for a small recording like this. So thank you all for joining. Hope you all had a great time watching this. I'm going to try to continue making as many of these as I can, and I hope to see you all soon. Happy coding. Later.